Okay, so the next thing we're going to talk about is the law of sines. Again, it's something you do in geometry, but it's a nice review. You'll use it in trig for sure, but it also appears on the ACT. So knowing these formulas is kind of a big deal. So in geometry, they teach you the axioms, which is the angle, angle, side, or angle, side, angle, or side, side, angle. Now these tend to confuse students because you get things out of order or you don't really understand how the axioms work. But remember, if you are doing like angle, angle, side would be like angle, A, angle, C, and then side. So they have to be in order, like as if you were reading them side by side. The way I remember it is a little different. I don't remember the axioms. I just remember for law of cosines, which we'll do in the next video. It really only works two ways. So if it's not law of cosines, then it has to be law of sines. So that's easier for me, but if you like to memorize the axioms and use those, please feel free to do so. So the law of sines formula is that the ratio of the sine of the angle over the side has to be the same for every side and every angle. Okay? Now the one thing that I would like to point out here is that this can be written like this. It's still a ratio as long as your corresponding parts are in the same place. So all of these have the sine of the angle on top and the side on bottom. All of these have the side on top and the sine of the angle on bottom. Doesn't really make a difference which way you do it. So depending on what you're looking for would be what you want to put on top, because that just requires you to do less steps. That's all that boils down to. It's not wrong to write it either way. It just requires you to do less math steps if you write the one you're looking for on top. Okay? So we already know that this is law of sines, so we don't have to try and figure out which axiom to use, but it tells you finding sides using angle, angle, side, or angle, side, angle. So if you look at this first one, they want us to find this. So this is angle, angle, side. So then I know that I'm looking for x. I'm going to put it on top. So that's my side over the sine of its angle. So its angle is the angle that's across from it. So 52. So sine of 52 has to equal the same ratio as 10. So side on top over sine of 34. So then of course we want to get x on a side by itself. So we're going to multiply both sides by sine of 52. So I get x is equal to 10 times sine of 52 over sine of 34. Okay. Then from here, it's just a matter of calculator, and I think it says to the nearest tenth, so it is an approximate answer. So I'm going to show you, this is the TI-84 plus CE, which is the fancy calculators in my room, but the keystrokes are the exact same for a TI-83. I know we've been using the small calculators, but there's no software out there for those. The keystrokes are very, very similar, but I will show you on the TI-84, which is what you could use on the ACT or the TI-83. Either way, the keystrokes are very, very similar. So I'm going to do 10 times, well, first I'm going to go to mode and make sure, see how I'm in radian? I'm not in radian, I'm in degree. So I'm going to do degree and hit enter, and then second quit. So I have 10 times sine of 52. Now I prefer to go ahead and hit enter, divided by sine of 34. So sine 34, enter. And I get approximately 14.1 degrees. I mean, well, it doesn't give me a measure. I don't know if it's feet, inches, but it's approximately 14.1 length. Not degrees, sorry. So number 2, exactly the same thing. I'm looking for a side. So I'm going to put x on top. over sine of its angle, so it's what it's across from, 119, has to equal the side 7 over the sine of its angle, sine of 21. So I'm going to multiply both sides by sine of 119. So I get x is equal to sine, or 7 times sine of 119 over sine of 21. So x is approximately equal to 7 times sine of 119 divided by sine of 21. And we get approximately 17.1. And again, it doesn't give me any measures. Be cautious though, because if it does, those would be, if it was meters or feet or inches, that would definitely be something you wanted to include. Okay, so number 3, so we have the same situation here, but I have a problem because I don't, so I would start with x because that's what I'm looking for, but I don't have this angle. But there is something that we know, and that is that there's 180 degrees in a triangle. So this angle has to be 180 minus the 2 given angles. So that would be 180 minus 64 minus 45 is 71. So this would be 71 degrees. So that would be sine of 71 degrees. Now I'm only given one other side, so even though I have this angle, I can't use it because I don't know the side. You cannot use Pythagorean theorem here. This is not a right triangle. So I have to use the one that's given. So that's 32 over sine of 64. So I'm going to multiply both sides by sine of 71. I get 32 sine 71 over sine of 64. So I get x is approximately equal to 32 times sine 71 divided by sine 64. So approximately 33.7. Again, it didn't give me any measurements. So this is the same thing in number 4. I just need to find this angle, and then I will use this angle and this side, and then these two to find x. Okay. So question 5 and 6, we're going to use the diagram given. So it says, how far is Kevin from Adam? So it wants this distance. Okay, so I need this angle, so I'm going to do that same thing. I know there's 180 degrees in a triangle, minus the 2 given angles are 71 and 86, so 23. So I have x over sine of 23 is equal to, I'm only given one angle and one side, so 25 over sine of 86. So I have x is equal to 25 times sine of 23 over sine of 86. So x is approximately equal to 25 times sine 23 divided by sine of 86. So that's approximately 9.8, and I think it gave me feet. Yes, 9.8 feet. How far is Dan from Kevin? So it wants to know this distance. We'll call it y. So y over sine of 71 has to be equal to the same ratio. So again, I probably wouldn't go with what I just found. I would go with what was given in the problem. So I would do 25 over sine of 86 again. So y is equal to 25 sine of 71 over sine of 86. So y is approximately equal to 25 times sine of of 71 divided by sine 86. Divided by sine 86. So I get approximately 23.7 feet again, because it gave me feet in the problem, right? Okay. So the next one is a little more difficult, and it's finding an angle. And notice it has a watch out. When you're finding angles, it's called the ambiguous case of sine, because it is possible to get two solutions. It's also possible to get no solution. So there's a couple things that you have to think about. The first is there's 180 degrees in a triangle, no more. You cannot have more than 180 degrees. You cannot have less. You have to have exactly 180 degrees. The second thing is side and angle ratio. Okay, that means that the biggest side should have the biggest angle. Okay, if it doesn't, then it's not going to work. It's not a triangle. Okay, so the sine function always has a range of between -1 and 1. That means if you are trying to get something out of sine, and when we try and find an angle, we use a keystroke called sine inverse. And what we do with sine inverse is we put in our ratio, and it gives me out an angle measure. Okay? That ratio has to be between 1 and -1. If it's not, then it's not a triangle. Okay? It's not a valid answer for sine. It's not a valid angle, so it's going to give me not a valid triangle. If the sine function is positive, then the angle can lie in quadrants 1 or 2. It's just a property of sine. So once you do this sine inverse and you get an angle, you're going to take that angle and subtract it from 180 degrees to get your second possible angle. I remember, just as I said a minute ago, the sum of the angles has to measure 180 degrees. And no triangle can have two obtuse angles. Okay? So a few things to kind of think about to determine whether we have one, two, or no triangle at all. Okay? Now, what happens with sine inverse here, if you'll look at like sine of 30 and sine of 150. Okay, so let's go to our calculator. So let's do sine of 30. We get 0.5. Sine of 150. We also get 0.5. This is where the ambiguous case comes from, because if we do sine inverse, so second, sine inverse, see how it's in blue, of 0.5, we only get one answer. We only get the 30. Okay, now, are you going to have a triangle with a 150 degree angle in it? Well, it's possible if the other two angles are less than 30 or equal to 30 degrees, the sum of the other two angles. So it is possible. So just be cautious that you just don't throw it away because you're like, oh, 150 degrees, that's not in a triangle, because it could be. But this is where the ambiguous case comes from, because the calculator only spits out one answer. It only gives me the 30 when I know that sine of 30 and sine of 150 give me the same answer. Okay, that's why we subtract from 180. This would be true with any measure subtracted from 180. So 180 minus 30 is where I got the 150, and that's why they're the same. Okay, so let's go back. It says information about the triangle is given. Check your answers and give all possibilities. Now, how you draw your triangle is totally up to you as long as it is labeled correctly. So I'm going to do A, B, C. Doesn't matter as long as you label it correctly. Okay? So angle A is 50. So side AB is 4. Side BC is 9. And angle, it wants me to find angle C. So I'm going to put an X in there. Okay, so I'm looking for sine of C. So I'm going to put it on top. and side of C is 4. So sine of 50 over the angle, or side A, is 9. Now again, you can set this up either way you want to. This just causes me the least amount of steps if I put what I'm looking for on top. So I'm going to multiply by 4. So I have sine of C is equal to 4 sine of 50 over 9. Okay? Now what I want to type in my calculator, just to make my life easier here, is I'm going to do sine inverse of 4 sine of 50 over 9 has to equal my angle measure. That's how I'm going to type it in the calculator, because you don't want to, I'm going to show you how to do it differently, but you don't want to round before you type it in, because your answer will be different. So if you want to type it in first, you can type in second sine of, so I need parentheses for my numerator, 4 times sine of 50 divided by 9. Okay. But you can also, so it gives me an approximate angle of 19.9. So that means that my x is approximately 19.9 degrees. And I'm going to find my second one in just a minute. But I also want to show you this. So I could do 4 times sine of 50 divided by 9. And I can make sure that this isn't going to give me an error message, meaning it's not greater than 1 or less than -1. Then I could do second sine, second, and then come down here. Do you see the blue A and S answer? Answer, which means it's going to put in this answer. Do not round. See, we get the same exact answer, 19.9. Okay, so don't round, but you can type it either way. If it happened to be a no solution triangle, which we'll do in just a second, you would just get an error message, and I'll show you what that looks like in just a second. Okay, so let's go back here. Now, to get my second option for an angle, I have to subtract this from 180. So I have 180 minus second answer, because I'm lazy, gives me 160.1. So 160.1. So then we have to look at that and decide whether it's viable or not. Okay, so is it viable for that angle to be 160 degrees? Well, I'm going to say no, because 160.1 plus this given angle of 50, that one has to be 50, is already greater than 180 degrees. So there's no possible way. So this is just a one solution triangle. So that's my only solution. Okay, so number 8, so this is a one solution. If you want to label it so that you know, this one is going to be a 2 solution. And if we'll look ahead to number 10, this one is going to be a no solution. Okay, just to kind of label them and get them in your brain. So let's look at number 8. So again, my triangle, A, B, C. Now if you want to label it different, it makes no difference whatsoever. So angle B is 37. Side AB is 47. Side AC is 29. And it wants us to find angle C. Okay? So if I want to find angle C, then angle C is what has to go on top. So then side C goes on bottom, the side across from it. And it has to have the same ratio as B here. So we're going to use B because that's what's given. So sine of angle B over side B. So I'm going to multiply both sides by 47. So C is going to be approximately equal to, so we're going to do the same thing, 47 times sine 37. Sorry. 37 divided by 29. Okay, it's not over 1, so I'm going to do second sine, second answer, and I get approximately 77.2 degrees. Okay, now remember we have to find the second option for my angle, and the second option would be that subtracted from 180, so 180 minus second answer. I get 102.8. Okay, so a couple of things that I like to check. First, so if angle C is bigger, which 77 and 102 are both bigger than 37, is the side bigger? Yes, 47 is bigger than 29, so that's a go. The next thing is 102 plus the thing that I know is given, 37, less than 180. And the answer to that is yes. So this is a two-solution triangle. So it could either be 77.2 or 102.8. Either one is viable. Okay? So let's look at number 10. So this is my no solution. So I want you to kind of see how that pans out. So I'm going to draw my triangle. A, B, C. So it says angle A is 114 degrees. Side AB is 34. BC is 12. And it wants me to find angle C. Okay, so if I'm looking for angle C, then angle C has to go on top. So sine of C over side C, 34, has to equal angle A, sine of angle A over side A. So sine of C is equal to 34 times sine of 114 over 12. So C is approximately equal to, so we go to our calculator, 34 times sine of 114 divided by 12. Now immediately I see that this is a problem because it told me that sine could not have an output or a range. So notice when we say sine of C is equal to this, this is the range, this is the output, okay? That cannot be greater than 1 or less than -1, and it very much is. But let's say you didn't catch that. Not a big deal. So we'll do second sine, second answer. And it tells you it's not in the domain of that function because it's the inverse function. So it's not in the range of sine, but it's not in the domain of inverse sine. Okay? So you will get that error message. So that means no solution. Because we get here that it's approximately equal to 2.6 actually. So it's a no solution. So that's what's going to happen if it's a no solution. So it's not like you have to go through several steps to figure it out. The very first option that you get will not work. Okay? Now, a good way to kind of double back and check is notice that this is 114 degrees and this side is 12. This side is 34, which means this angle has to be bigger than 114 degrees. There's no way that angle can be bigger than 114 degrees and actually have a triangle. Because remember, they have to sum to be 180 degrees. So if it's over 100, it's already more than 180 degrees. Okay? So we can do number 11. So ABC. Again, you can label it however you want to, just as long as you label the correct things. 47. AB is 33. Sorry, it's 47 degrees. And AC is 26. Find angle A. Okay. This one is mislabeled. AB is 33. AC is 26. So I need BC. Oh, okay. They want us to do this in 2 steps. Okay, so as I said, I was assuming the problem was just mislabeled, but they're wanting us to do this much more difficultly. Okay, so I don't have a way right now to find A. Okay, so to find A, I need this side, and I don't have it. What I do have is enough information to find angle C, and then once I have angle C, I can figure out what angle A is by subtracting from 180. Okay, so I'm going to do sine of C over side C is equal to sine of B over side B. So sine of C is equal to 33 times sine of 47 over 26. So C is approximately equal to 33 times sine of 47 divided by 26. So less than 1, so I feel good about that. So second sine, second answer, and I get 68.2. So approximately 68.2 degrees. But remember, we have to subtract that from 180 to get our secondary angle. So 180 second answer. Try again. 180 minus second answer. So I get a 111.8. Which are both viable solutions. They're both larger than 47, and the side of C is larger than 47. So that means that angle A has 2 possible solutions. The first is 180 minus 47, the given, minus 68.2, which is 64.8. And then we have angle 2, which would be 180, the number of degrees in a triangle, minus the given 47, minus my second option, which was 111.8. So angle 2 could possibly be A2, 21.2 degrees. Okay, so on page 6 of your packet, I would like you to practice 1, 4, 7, 8, 12, and 13. Now the entire key is uploaded. You can practice any problems that you want to. These just kind of vary with finding sides, angles, 1 solution, 2 solutions, no solution, and then I think 1 word problem just to make sure you can set the triangle up. Okay.